Hi, you guys. It is Miss Moran, and we are looking at our first video on limits. So this is Unit 1, Lesson 4, in our first video. So I'm going to have you guys make sure that you grab your notebook and graphing calculator. And while I would normally have you guys be able to use Calculate 84, it actually does not work for the feature that we're going to be using it for today. So that would make this a little bit challenging if you don't already have your own graphing calculator. It's not impossible, and it's something that we can walk through and figure out how to do. Without a calculator, or without a graphing calculator, you can do it with a scientific, or you can do it on your home screen of your graphing calculator. But the feature in the tables does not work on the Calculate 84. All right, let's go ahead and get started so we don't make this too long. So we're actually going to be starting with a definition of what is a limit? Like, what is this idea? The limit tells us the value a function approaches as the function's input gets closer and closer to some number. So that's very formal, and if you'd like to pause and write that down, please do, because it is a nice formal definition. It's actually a simple definition, but still looks pretty complicated. But we're going to focus on a couple words here, and the words I want to focus on are the value of the function and the input. So the limit tells us the value of the function. So that means that the outcome is the value of the function. And a value of a function is y. So if I said, what is the value of this function at a certain place, you would put in an x and get out a y. So the value of the function is your output. The limit tells us the value of the function approaches. So what y value are we approaching as the x is getting closer to some number? So that's it. Again, sounds a little confusing, so we're going to go to a graph to help us understand this a little bit more. So here I have the graph of a line, a very, very simple function. It's a line. And if I'm talking about approaching, so I want to say, I want to, x is getting closer to a number. So let's say I want x to get close to 4. So x is getting close to 4. The question is, what is the y value? What is the function value? So that's what I'm really looking at. What is y when we get close to x equals 4? So I have to look up on the function and say, what is the y value when we get close to x equaling 4? In this case, it's very simple. It's a line, and we can easily find it. And we would say, then the limit equals 6. And that's just the limit equals 6 as we approach 4 on this particular function. Okay, so let's take a look at another one, or it's just another picture of the same one. And here's the idea again. So as we are approaching 3, so as our x values are getting close to 3, our y value, what's that going to be? What's our y value? Our y value is 5. Okay, so that would be the outcome of this. Let's look at a couple other pictures. So here's one that's not a line, a little fancier curve that we've got going on. Again, as x is getting closer to 3, so as x is moving into 3, what is y? So we're always asking the question, what is y? And we say, wait a minute, there's a hole there. Y is nothing. Y doesn't even exist there. There's no value there. But the truth is, we can actually approach a hole. So I want to point that out. We can approach a hole. We can write it down. Approach a hole. Okay, now if I said, what is the y value? You'd say, there isn't one, because there is actually no point there. It's an open circle. But if I ask you about the limit as we're approaching 3, you'd say, the limit's 2. The y value is 2 when we approach the x value of 3. So that's something to kind of keep in mind. Just because there's no y value there does not mean that the limit doesn't exist. There are cases in which a limit won't exist. This is not one of those cases. All right, so let's look at this one. So here we've got one where we've got a hole, but we've got some other random dot that seems to be in the same x value. So x is 6, and so we'd say, well, if we're kind of coming in close to the value that should be there, but that value isn't there, that's okay. The limit is -3. The function value actually is -5. So I'm going to skip ahead. Actually, I'll go back. We'll go to this one and I'll go back to that last one. Here's our formal notation for this. And you may have seen this if you had taken a class last year and did a little bit of limits at the end of the year. But I don't really know what that all looks like for many of you. So the limit of, that's how this is spoken, the limit of the function f, and maybe it would be, maybe it would actually be the limit as x approaches, I don't know, 2 of, and you'd actually see x plus 7 there or something. You'd actually see a function in its place. Or maybe instead of x plus 7, you'd see like the square root of x minus 2. Okay, so this spot right here where it has the f of x can actually be filled in with what you might call an equation, but it's a function, okay? So it can be filled in. It doesn't have to just say f of x. Sometimes when referring to a graph, we call it f of x because we named the graph f of x. So this is very general, but it's a formal notation in how it's pronounced. The limit of the function f as x approaches 3. Sometimes I switch around and I say the limit as x approaches 3 of the function f. So we can do that in kind of two different ways. You could do the limit as approaches and then of the function, or you can definitely go in the way that I said it first, which would be this way, and then as it approaches 3. Either way, we're still communicating the same thing in a very formal way. So I'm going to go back to our last example. If you need to pause and I'm going too fast, please go ahead and pause. Okay, so I'm going to look at this one, and I'm going to ask 2 questions about this picture. I'm going to ask what f of 6 is. I'm going to erase my notes here because we're looking at it again. So if I want to know just what is f of 6, and then I say, well, what is the limit as we approach 6 of the function? Okay, so the value f of 6 is always going to be the solid dot, always, wherever that solid dot is located. So wherever there's a solid dot, that is our f of value. So we'd say, well, that's -5. The limit means you have to literally be tracing the actual function. I recommend, and this works better, of course, if you've got paper in front of you, but you'd be taking your left finger, so you have to imagine my left finger is touching the screen as I draw that arrow, and then my right finger is touching the screen, is touching the screen as I draw the other arrow. So as my left finger and my right finger are sliding along, smoothly moving along this graph, what are they approaching? What is the value that they would get to if they were to meet? Okay, what value would be there if they met? And the answer would be -3. So this is a place where you actually get 2 different outcomes. If I go back to this screen right here and I were to pick any spot, we would say, well, it approaches the same thing that its function is. So here, if I say the limit as x approaches 3 of our function, the answer is 5. And if I say what is f of 3, we'd also say 5 because there is no hole, okay? In this case, so I know I'm jumping back, but in this case, we would say that f of 3 does not exist. There actually is no y value there. That doesn't mean the limit doesn't exist, because my limit as we approach 3 of this function is 2. Well, why? Well, because I'm approaching it. I'm not actually standing in it. So this idea is, can you stand there? No. Can you approach it? Sure, I can approach it. Okay, so again, go back if you need to. Now, we also have something called one-sided limits. And one-sided limits can be done on any of the graphs that I just showed you. You would just use one finger. you would use the finger from the left or from the right. So let me make sure you understand that notation and what it looks like. So if I have the limit as we are approaching, in this case it is 3 again, and I put a little plus sign after, okay, then this is saying come from the right. So this is a right-sided limit, okay? If I did the same thing, but I said, let's approach it from the left, it looks like there's a little negative sign up there. It's indicating from the left. So this is a left-handed limit. Now, all I'm suggesting you do is think about it as your finger is sliding along and it's coming from the right. You're not going to the right, you're coming from the right. So of these two pictures, which can I actually take my right hand and slide it across into the location? And that would be this side. So I would say, well, if I come in from this side, I'm approaching a height of 6. So from the right, the answer is 6. And if I come in from the left side, then I'm approaching a height of 4. So now you say, well, wait a minute, there's a hole on 4. You're right. We can approach holes. Don't forget, we can approach a hole. The question is, what is it getting close to? Okay? So imagine that there's a sidewalk and they're repairing one of the little rectangle pieces of the sidewalk. Okay, you and your friend can walk towards each other on that sidewalk from opposite directions. You can walk close to each other. You don't want to stand in the hole, but you can approach it. Okay, that's okay. So that's the idea here. Now, in this case, you're on 2 different streets. You're never going to meet each other. Okay, so you got one person on one street and one person on the other street, and they go, wait a minute, we're not going to even meet each other. So in that case, well, let me go back. In general, we would say that the general limit, the limit as x approaches 3 generally, so a non-directional. I'm not saying from the left or from the right. I'm just saying as we approach 3, the fact that my left hand and my right hand would never touch means that this limit does not exist. Okay, so we can have one-sided limits that do exist, whereas the general limit would not exist. So some questions to ask yourself. Is this a one-sided limit? If yes, then come into the x value from that side. Okay, can you move your fingers smoothly until they meet? Because if you can move them to where they meet, then that's what your limit is. Remember that function values can approach a hole. So these are just some things to write down or really keep in your mind. All right, let's talk about making tables. Now, my intention was that you could do this on the Calculate 84 app. However, when I tried it right before making the video, I found out you cannot. So asked a bunch of other teachers, and they also said no, that they were unable to. So there's a few features, and we just discovered one of them that doesn't work on the calculator. So I'm going to switch to my camera and hold it over my calculator screen to see that this works. And I'm going to give you the directions as to how we can use our table for evaluating some limits. So bear with me on this one. Okay, so the steps that we're going to use, and this is going to kind of jump with my focus, and I apologize for that, is you're going to go into your y equals screen, okay? And you're going to type in your function that we're working with. So I'm just going to go with a really simple one here, and I'm just going to use x plus 2. Okay, so there's my function. If we're using anything involving a numerator and denominator, don't forget to use your parentheses, or if you have that really awesome alpha y equals, so if you press alpha and then y equals, if it works on your calculator, old operating systems don't have this, but most of the ones you probably have work this way. So in that case, you can go ahead and use this numerator denominator, and you don't need parentheses, but if you don't have that option, you have to use parentheses. All right, so I have my y equals, I have it entered. The next thing you're going to do is to go into second window, and you're going to arrow down to change the independent to ask. Okay. Remember, you can always rewind this or pause it and see it again. So I just want this highlighted on ask, and I just did that by pressing enter. Now I'm going to go over to my table, and it's going to be blank. And normally it would have all these numbers in it, and I can scroll up and down. But what we just did is we asked the calculator to allow us to choose the values that we want. Now, because I'm going to be, an idea would be to approach, like, let's say we want to approach the number 5. I want to think of it as, what is a number that's just a little bit smaller than 5? And if your first instinct is 4, we need to be a lot closer to 5. So I'm going to choose something like 4.9. And I say, well, I bet I can get closer to 5. 4.99. Maybe I'll get even closer to 5. Oops, see, I'm doing that underneath my 0.999. Okay, so these are how I can get closer. Now, what if I wanted to be a little bit bigger than 5? I don't want to choose 6, that's too far away. So I'm going to choose 5.001, that's 3 digits. So just like the 4.999, I did 5.001. And then 5.01, that's 2 digits, and then 5.1, that's 1 digit on the right of the decimal. What I can see from this is the y values are approaching 7. As my x is getting close to 5, my y is getting close to 7. And I always want to choose the outcome for y's. Y's are getting close to 7. So that is the process that we would use on our graphing calculator. So we would, again, use the y equals to enter it. We want to go back to second window and make sure that it says table set ask on independent. And then you can go right to your table and you can start entering. Unless you clear your table out, these will always be there, and then you can just type the next one. So if I'm approaching 2 on the next one, I would just retype and go 2.9 and just type over it. Don't worry about needing to clear it out. You can just type right over. If I ever want to turn that feature off, I just go back to second table set and I make sure it goes back to auto. And now when I go to my table, it'll have all of the values, like there's all of my normal values, counting by 1. So all my integers are right there for me, okay? All right, so let me get back to our screen. Here we are. So those are the directions that I left for you. So you definitely want to write those down if that's something you need to view again. And here are some examples that we can try. So I am going to make a Schoology post with the answers for these two because I haven't figured out how I can pause my video on the iPad as I do this in order to give me the time to get the correct answer for you without making the video super duper long. So I'm going to go ahead and just leave the answers on Schoology for these two problems, but I encourage you to just try them to get the practice and know how that you're going to type them into the calculator and use that. Other than that, I would like you guys to work on the Math Excel assignment. It's going to have tables and graphs for finding limits. And that's it. You guys have an awesome day, and we will chat soon.